In this picture, there is the smallest statue ever made. Its height is only 0.1 millimeter. To understand how actually small it is, the thing that the statue steps on is a human hair. It is so small that it can comfortably fit inside the eye of a needle. But what is really meaningful, it's not the statue itself, but rather the story that conceals its creation. The author of this work wanted to fuse together art with science. By his own words, art is the thing that will add a layer of empathy on our modern science. Art gives us a perspective, science, the technique. This statue was made with a 2-photon lithography system, which is a sort of 3D printer, but of the nano world. But we can go further than that. What I show you is a stack of circuits put one on top of the other. In this way, we can improve the computing performance of microchip, enlarge the memory of our phone, or to have smaller electronic devices. And all of this is possible because a new field of science emerged in the last century that breached every aspect of our life. Nanotechnology. Nanotechnology is the science of designing, producing, and manipulating matter at the nanoscale, which is the scale spanning from the dimension of a bacteria down to the single atom. Most of the micro and nanotechnology is focused on consumer electronics. However, other new exciting applications are opening. As an example, how many of you have fears of syringes? Well, there is a good news. These hollow microneedles are just like normal syringes, but they have the dimensions of 1/10 of a millimeter. So small that we can use them as a syringes, but without harming the skin and causing pain. But we can go further than that. Some time ago, the IBM Research Laboratory released this movie. Yes, a movie from IBM, and it is named A Boy and His Atom. Using a very sharp metallic tip, they scans over the surface of a copper plate. On top of this plate, there are these tiny spheres, which are carbon monoxide molecules, which are made of only one atom of carbon and one atom of oxygen. Then, using a very small current on this microtip, they scans over the surface in order to image those atoms and even move them on the surface, thus creating the frames of this movie. Okay, this is the movie that we can make, but why are we so interested into the nano world? Because at the nanoscale, the world of physics behaves differently. Imagine to throw a glass bottle from the 10th floor of a building. Once it arrives to the ground, it will break, right? Now imagine to throw an ant from the 10th floor of a building. And without any surprise, the ant will survive. And it can survive because of its scale. Every day, we breathe air to survive. But we don't really feel it, right? The ant instead feels the air very differently, as a thick, dense, viscous media that slows down the ant descent, saving its life. Actually, there is another thing that changes with scale, and it is heat propagation. A common material heated on one side propagates its energy smoothly along its length, and we will have a linear decrease in temperature from the hot side to the cold side. However, for nanosized material, things can be very different. If we heat a nanosized material from one side, the temperature increases and decreases just like a wave will do. Similar to sound in air, the heat propagates and efficiently reaches the other side. Indeed, these materials are the best heat conductor in the world, and we can use them to better dissipate heat in microchip to improve computing performance. However, to characterize these nanomaterials, you need the right tool. What I show you is a micro device that can measure nano-sized materials. And this is the essence of my PhD project. It is made of 4 thermometers, here on the side, that can probe the tiniest variations of temperature. A flake, that in this case it's a flat piece of boron and nitride atoms, lays at the center. If we count the number of atoms along its thickness, we will have only around 100 atoms. We made this device to study the heat properties of nano-sized materials. Of course, you cannot use a typical thermometer. You need a tool as small as your target material to probe the variations in temperature. It is black all around it because the device is suspended, which means that we have isolated the flake from the environment to accurately measure the properties that we want to obtain. Moreover, we can combine this system with electric field, magnetic field, and powerful laser to have a complete picture of the material. But let me ask you a question. How many times have you set a goal for yourself and things that you have not expected happened? All the time. And this is the same with science. Because to make this micro-sized device, we had to work in the cleanest environment to avoid contamination, with the most sophisticated system to achieve nanometer resolution, and repeat our experiments 1,000 times before we figure out the right way to do it. And before we succeed, I guarantee you that we failed many times. Many times. But how our experiment actually look like? As an example, we can take a piece of solid material, like silicon, and we cut a tiny piece out of it. This piece has 30 microns in length, 5 microns in width, and 250 nanometer of thickness. And it is defined as lamella. Then, using a microtip that you can see here on the right, we pick up the lamella and transfer it on top of one of our already suspended device. Now the lamella is in touch with the thermometer, which probes the variation of temperature on the 4 sides by applying a small electric current. Moreover, we can combine this system with a laser that can probe the temperature of the lamella in different points. In this way, we can extract the heat flowing through the lamella and thus characterizing its thermal properties. So, in the end, what our research is really about. With our micro device, we study the heat properties of different nano-sized materials. We test them, twist them, stretch them, and test them again in order to find all of their qualities and select the best one for an application. And who knows, alongside our journey, we may also discover something that we did not expect and surprise ourselves with new sight of nanomaterials. Thank you.